my screen, not my TV monitor. I hope. I'm scared about that. We'll see. We'll see in a little bit. All right, I'm going to use my Word document today because I'm going to be writing notes. So let me fix the resolution. There. Okay, now the first thing we're going to do is going to be the first and second derivative. Okay, this is out of Unit 2, I think, or Unit 3, I can't remember. It's right after the definition, it's right after we did the derivatives. So I think it's Unit 2. I'm not sure. All right, now, we talked about the first and second derivative giving us the, and I am recording, the first and second derivative actually giving us the velocity and acceleration, the marginal cost, the different, but I also told y'all that the first and second derivative, first derivative will give us the increasing and decreasing values. And the second derivative will give us the inflection point. Now, a good example of this, if I give you something that looks, if I give you a graph, and that graph looks something like this. Okay. Well, I've got a vertex here, and that's called local max. And then this is called the local what? If that's called the local max, what do you think this is called?
The minimum. I've been talking, but my mic was muted.
Thank you. Okay. All right. So the first derivative will give us these values, and these values. And the second derivative will give us this point right here. Can somebody give me the definition of the inflection point? Can anybody give me a somewhat definition of an inflection point? The inflection point is the point between concave up and concave down, or concave down, concave up. So right here, the inflection point, this is concave down. And this is concave what? Concave up. And the second derivative will give us those values. Okay. Mr. O'Quinn, are you with us today? You got a microphone working?
He's texting in the chat.
I'm sorry, what?
He's messaging in the chat.
Oh, I heard.
Lights up like he's talking, but he's not.
I just got the mic set up.
You are talking. I hear you.
I'm here. Yeah.
Well, good. I'm glad because you're the only one that talks to me. Miss Sterling and Miss Hart took up your slack, but it didn't. I mean, I didn't get much out of them. So glad you're back. I'm trying to turn on the chat so I can see if there's any talk. I mean, any questions or whatever. All right, so does everybody see what we got here? So if I give you a question on the test on, next week after the last day of class, and then asks for first and second derivative, that's where this is coming from. So if I have a function that is increasing, if my function is increasing, then my first derivative is increasing. that means I have a positive slope. Now, this is just some information. I'm not going to test you on this, but if my function is decreasing, then my derivative is decreasing, and I have a negative slope. And of course, if f of x is constant, that means we have what for a derivative? 0. So therefore, horizontal line, which means the vertex, which means it could either be the maximum or the what? The minimum. So let's go ahead and look at a few examples. So here's our first example. Now if I was you, I would pay very much attention to these examples that we do today. Hint, hint. F of x is equal to x cubed minus 3x squared plus 5. Now, of course, the first thing you're going to do is take the first derivative. So f prime of x is equal to 3x squared minus 6x plus 0. So there's your first derivative. Okay, so after you take the first derivative, you're going to set equal to 0. And of course, you're going to factor out that 3x and make it easier. So 3x times x minus 2 is equal to 0. So our values are x is equal to 0 and x is equal to 2. I'm going to put a circle around those. Those are called our critical values. Well, I thought that was a z. I thought that was x-intercepts. No, when you set this equal to 0, you get the x-intercepts. When you set the first derivative to 0, you get your critical values. They're also called critical points. Some people call them critical points. Okay, those are the numbers that you put on the number line. So I draw a number line. Negative infinity, positive infinity, 0, 1, 2, -1, -2. And I'm going to highlight in yellow or green. Where's my green highlighter? I'm going to highlight my 2 critical values in green. Now I need to test my other values. So of course I'm going to pick 3. And I'm going to plug 3. What's 3 times 3? That's 9. And 3 minus 2 is 1. I'm just checking for signs. So a positive 9 times a positive 1 is what? Positive.
You have a working.
Okay, now you plug in 1. Will 1 give you a positive or a negative answer?
Negative.
Good job. And then what will happen when you plug in -1?
Positive.
No, negative.
Positive.
Is it? Oh yeah, never mind. Negative.
You got to be careful on these. So I know that I'm decreasing here. I'm sorry, I'm decreasing in the middle. Sorry. I'm increasing here. I'm decreasing here. And I'm increasing here. Okay, so that means that I'm going up, then I'm going down, then I'm going up. Okay, so I'm just going to draw a sketch down here, very nonchalant. Okay, so that's what the first derivative tells you. Now we're going to do the second derivative. So I'm going to draw a line down through here. And now I'm going to do in magenta, I'm going to do the second derivative. F prime of x is equal to 3x squared minus 6x. And now I'm going to find the second derivative. F prime of x is equal to 6x minus what?
6.
6.
6. And now set that one equal to 0. So I'm going to draw a number line. Negative infinity, positive infinity, 0, 1. So 1 is our, I can't use that. I'll have to use yellow because magenta and red won't go together. 1 is our critical value. So plug in 2. 2 minus 1 is a positive number times 6 is positive, which means concave up. And then 0 will give us a negative number, which means concave what?
Down.
And we know that 1, x is equal to 1 is our critical value. I mean, this is our inflection point. So if you want to know which point is the inflection point, you take that 1 and plug it in here. 1 minus 3 is what? Negative 2. Negative 2 plus 5 is what?
Trace.
3. So 1 comma 3 is our inflection point. Now, we've just done all of this and we have no idea what the graph looks like. Okay, that's why they want you to learn how to use the first and second derivative. Okay, yep, this is business calculus. In fact, this is the last unit in business calculus in 130. So now let's take our handy dandy calculator, which I had up here, but now it's gone. Damn Russians. And let's see what it looks like. So y is equal to x cubed minus 3x squared plus 5. Graph. And I'm going to zoom fit. I don't know if that'll work or not. Zoom 0. That's good enough. But you got decreasing. That looks like it's not decreasing. So what you're going to have to do is zoom box. I do zoom box. You can use your window feature, but make sure you get a good representation of that area, because what is hidden behavior? Hidden behavior is when you think something is going on, but it's not. So, and you got to blow it up more, but you get the idea. If I was to sketch this graph based on my, oh man, trying to find everything. I'm trying to maneuver everything around, and I'm not in the mood to maneuver stuff around. Sorry. Hold on. There. And I've lost my... Okay, if you take this information right here, I already drew some kind of a S curve here. But you have to go and sketch it. You go, okay, well... I know that my point of inflection is 1, 3. 1, 2, 3. Okay, I know that I've got the difference between concave down and concave up right here. So I know that I'm going to have some kind of transition right there, but I know that I've got negative values between -1 and what? +1, right? No, 0 and 2. 1, 2. So I know between 0 and 2 that I'm going what?
Down.
Down. So now all you got to do is just, so here we go. Something like that. Now to see this hidden behavior right here, you're gonna have to blow that curve up just to see the hidden behavior. It's there, but you're gonna have to blow it up. So you take your handy dandy calculator, which is right here, and I'm just gonna zoom in one time instead of using, since we know what it looks like now, and I'm just gonna put that cursor right there. And right in here, from 0 to 1 or wherever 0 is, it's decreasing. And you need to, if you need to blow it up, you can. And again, sometimes that's why you need to use the derivative, because you can't see it. And that's why you need to use the first and the second derivative. All right, so let's do a nerding. I got like 3 examples for you. Hey, 3 good test questions. All right. I think I just did that one. Yeah, I just did that. Oh yeah, let's do this one so it can discourage you. F of x is equal to x squared minus 1 squared. Now, of course, you can do it 2 different ways. Let's hear the ways you can do it.
Product rule.
You can use, well, not product rule.
Chain rule or algebra, and then
You could
Oh,
use
that's
chain
right.
rule or algebra.
Yeah.
I don't care which one you use. Not inflection.
You forgot your L. That's why I was
Okay,
laughing.
leave me alone, okay? Treat me like a wife, okay? Think that I'm like a wife. In other words, I don't do anything wrong, okay? All right. So if you broke this out, that would be a minus b quantity squared. You could rewrite it fx equals x to the 4th minus 2x squared plus 1. Okay, you could do that. And that's the algebra. Please make sure I did it right. And then you could go over here, or I could just, I'll just do f prime of x is equal to 4x to the 3rd minus 4x plus blank. All right, so I did algebra right there. Now I'm going to do the chain rule. The chain rule, I'll just go over here. F of x is equal to x squared minus 1, and f prime of x is equal to 2 times x squared minus 1 to the 1st power times derivative of what's inside. So that's going to be f prime of x is equal to 4x times x squared minus 1, which is 4x to the third minus 4x. It's a miracle.
Oh my God, they're the same.
Yes. Now, I'll give you a little hint. If everything's going right, you did both of those methods without a single hesitation. Okay? That's how you can judge if things are clicking. If you could do both of these, or if you just did the chain rule. If you did the chain rule and you didn't have any hiccups, then that means things are good. If you're going, then things are not good. Hopefully nobody's doing that. All right, so set equal to 0. 0 is equal to 4x to the third minus 4x. Did I mention that all this is algebra? 4x, that's x squared minus 1. And that's 0 equals 4x, x plus 1, x minus 1, x is equal to 0, negative 1, and positive 1. Number line, positive infinity, negative infinity, 0, 1, positive 1, 2, negative 2. And I'm going to highlight my critical values. The reason you need to highlight your critical values is so you know which numbers to pick. So 0, negative 1, and positive 1. So we got to check 0.5 and negative 0.5, 2 and negative 2. So negative 0.5, positive 0.5, and 2 and negative 2. Now, are you worried about the numbers, or are you just worried about the sign?
Sign.
You're just worried about the sign. So if I plug in, and let's plug it into this one, or you can plug it into this one because they're pretty easy. So let's take 2. If I take a 2 and plug in here, that's going to give me a positive. If I take a 2 and plug in here, it's going to give positive. If I plug in a 2 right here, it's going to be positive. So positive times a positive times a positive is what?
Positive.
There we go. If I plug in a negative 2, negative 2 will give me a negative right here. Negative 2 will give me a negative right here. And a negative 2 will give me a negative right here. What's a negative times a negative times a negative?
Negative.
Negative.
And if I plug in a negative 0.5 right here, I'm going to get a negative. If I plug in a negative 0.5, I'm going to get a positive. If I plug in a negative 0.5, I'm going to get a negative. Negative times a negative is a positive. Positive times a positive is what?
Positive.
So those are positive. And 0.5. 0.5 is going to give me a positive here. 0.5 is going to give me a positive here. And 0.5 is going to give me a negative here. Positive times a negative. Negative. So we know we're decreasing here. Increasing. Decreasing. And increasing. Now I'm going to let y'all do the second derivative. I want you to do the second derivative of this and set it equal to 0 and tell me what the inflection point is, or inflection points are. So go ahead and do that. I'll turn to the next page as soon as y'all have a minute or two to start. Now, I might also pick out some problems to do the rest of the week and the weekend. Am I talking 20 or 30 problems, or am I talking 5 or 6 problems? Probably 5 or 6. So f prime of x is equal to 4x cubed minus 4x. And I'm going to give y'all another minute to finish it and tell me what the inflection, and go ahead and try to sketch it if you can, and after you sketch it, try to graph it. Let's see, I can factor out a 4. And that gives me what? 3x
3x
squared minus 1. 4 is equal to 0, which is not true. And 3x squared minus 1 is equal to 0. 3x squared equals 1. Divide by 3. X squared is equal to 1/3. Square root of both sides. So x is equal to positive or negative square root of 3 over 3.
Yep.
Okay, so we're going to draw a number line. Say again?
It's a parabola.
Okay, well, it's not going to be a parabola, is it? It's going to have a little bit of something because you got negatives and positives. You got increasing and decreasing. So it's going to look like a parabola, but it's going to have some kind of hidden behavior in there. Okay, so somebody take the square root of 3 over 3. What is that? 1.7, 1.6 over 3. What is that? 0.5? 0.55? What is it?
0.577.
Okay, 0.58. So here is 0. Here is negative 0.58. And here's positive 0.58. So I'm going to highlight my 2 critical points. So, well, they're not critical points. They're basically inflection points. I'm going to plug in 0 because that's the easiest one to plug in. So 0, plug it in right here. 12 times 0 is 0. 0 minus 4 gives us what?
Negative.
Negatives. So I'm going to plug in 1 right there. 1 minus 1 times 3, that's a positive. I'm sorry. Well, 4 times, that's good right here. 1, that'd be 3 minus 1 is positive. That's positive. And negative 2, negative 1. Negative 1 squared is 3 minus 1, that's positive. So it looks like we've got concave up there. We've got concave down here. And we've got concave up there. So I'm going to go to my next page. And I'm going to write down what we have on the 2 number lines. On the 2 number lines, we've got Wait a minute. Here we go. Getting all my papers mixed up. We got -2, -1, -0.5, 0, +0.5, 1, and 2. And we've got the 3, -1, 0, and +1. And we've got decreasing, increasing, decreasing, and increasing. And then on this number line, we've got 0, -1, +1, and then we've got -0.58 and +0.58, and we said that we've got negatives here, which means concave down, and we've got positives here, which means concave up, and we've got positives here, which means concave up. And here we've got decreasing, increasing, decreasing, and increasing. So it looks like to me we got some kind of saddle going on here. That's what it looks like to me. And it looks like to me that -0.58 is right there, and +0.58 is right in there. So somebody take -0.58 and plug it into the original formula for me, please. Take -0.58, square it, -1, and raise it to the second power, and give me a y value, please. And I know -0.58 is not precise, but it's close enough for government work. So what is -0.58 squared -1 and then squared? It's going to be positive. What is it? And then somebody do 0.58 squared -1 squared. Should be the same y, but go ahead and check it.
For the second one, I got 0.440.
Okay, it's going to be the same. So 0.44. So I'm going to draw my big graph here. And I know my y-intercept, if you plug in 0 squared, let's see, my y-intercept is going to be 1 because the y-intercept is 1. We know this point is 0.58. There's 1 and there's 1. 0.58 and 0.44. 0.58 and 0.44. So there's our concave down. And then, of course, I'm just going to draw it like this. So let's take our handy dandy calculator. Y is equal to x squared -1. So parentheses. Turn the damn thing on, Hubert. Y is equal to parentheses x squared -1 raised to the second power. I hate these things. God, I hate these things. Delete, 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 delete. And there, now it goes backwards. Now it goes backwards again. I'm sorry it takes me so long, but I don't know how this calculator works. I've never seen delete button turn into a backspace button. I know what it is. It's them damn Russians. -1.
What are you gonna do the day you get a Russian student?
I've had Russians. They laugh. I had a couple of Ukrainians last semester. They'd laugh too. Raised to the second power. Listen, after I had, I didn't tell y'all about the black sheep. I told everybody I was the black sheep between me and my sister, and I had somebody come up to me and say they were offended. This was in 2004, because I remember we were in Cleveland Hall because Oconee Hall was being renovated, and I was teaching in Cleveland Hall, and the student said that they were offended because I used black in black sheep as a negative connotation. I said, well, until you can tell me what a non-white sheep is called, I'm going to continue to call it a black sheep. All right, so graph.
It's a
And I'm
sheep
on
of color.
Zoom standard or Zoom Fit, whichever one. Let me Zoom standard. What is Zoom standard? Zoom what? 6?
6, yeah.
I'm trying to get a big, there we go. There's that dang old saddle. And we predicted it. How about that? Dang old first, second derivative. Dang old teaching us what it looks like. Don't y'all feel good about yourselves? Oh, man. You know, I thought y'all were going to be an outgoing class. And y'all turned out to be.
My graph didn't show the little squiggle in the middle.
Your what?
I graphed that, but my graph didn't show the little squiggle in the middle.
Well, you need to zoom up a little bit, or you didn't type it in correctly.
Probably just need to zoom in.
All right, you ready? F of x is equal to x times the square root of x plus 4. Oh my God, what do we got to use now?
We just quit. We don't use anything.
Oh, yeah, there you go, Mr. O'Quinn. The product rule. Got to rewrite it first. F of x is equal to x times x plus 4 to the 1/2 power. All right, get to work. First and second derivatives. It is better since I've put in my I got like a 42-inch monitor, so I can see. So now I can probably start using that whiteboard now that I can see the class. I didn't like doing it when I couldn't see the class, which took me a whole semester to get. Well, it only took me, what, 2 or 3 weeks to get this whiteboard set up, but I got it set up now.
Good thing we have a week left.
Well, it's going to be all over in November anyway.
I'm so proud for your next class.
Yeah, well, I'm going to be teaching from the Anderson campus, so I'm going to be teaching just like I am now, except I'm going to be more on the board. I'm going to be teaching 110, 111. No, I think I'm going to be teaching 110, 111, 2 120s, and some. So I got 6 or 7 classes next semester.
And then next summer, you're going to the Pendleton campus and teaching 141.
No, I'm not. No, I'm not. Sorry. I can't hang up there. I'll end up.
I can't either. That's why I need you up there.
I'll be glad to help you tutor. I'll be glad to do any of that, but I can't handle people up there. They yuck people, as my father said. Yuck. Yuck people.
I know a few of those.
Yuck people are the people that just you don't talk to. You don't, kind of like my ex-mother-in-law, you never ask them how they're doing because they tell you. Oh, I got the Chinese flu and I got this and I got that and I
You're
worked
just supposed
50
to say,
hours.
"Good, how are you?"
I worked 50 hours yesterday and there's only 24 hours in a day, but I worked 50 yesterday. And my dog died and my cat's sick and ugh. So here we go. F prime of x is equal to first times the derivative of the second. Thank God we got the chain rule. 1/2, I'm going to do that in green or another color. Let's do orange. 1/2 x plus 4 to the negative 1/2 times 1, because the derivative of x is 1, plus the second. I don't know why my hand is freezing. Times the derivative of the first, and the derivative of x is 1.
Missing something.
I'm sorry, what?
Missing something.
First times the derivative of the second, plus the second times the derivative of the first.
When chain rule apply.
There's a chain rule right there.
Oh, it's not one. Yeah, sorry. The one. I'm missing the one. That's my fault.
Okay. Yeah, right here. I didn't put it. I just right here. Okay. Now I'm going to go ahead and skip down. You can clean this up. Well, I better not. I better do it. So f prime of x is equal to, I'm going to bring this down. And that's going to be x over 2 x plus 4 to the 1/2 plus x plus 4 to the 1/2 over 1. Now, if you get a common denominator of 2 times x plus 4 to the 1/2, if you do the algebra and add these together, you're going to, you're going to get 3x plus 8 over 2 square root of x plus 4. So f prime of x is equal to that. And just to give you a little hint, if the common denominator is this, then 1 will go into that many times. So you're going to multiply this by, I'm going to put it in pink, times 2x plus 4 to the 1/2. And somebody tell me what 1/2 plus 1/2 is.
A whole.
And that would be x plus 4 to the 1, and then you distribute that 2x with the, I'm sorry, you put this right here, and that's going to be 2x plus what? 2x plus 8, and then what's 2x plus x?
3x.
Okay, so that's all algebra. You should be able to do that. All right, now, here's our number line. And now we got a fraction here. So I've got to set the numerator equal to 0 because that'll give me 0. 3x plus 0 divided by 100 is 0. So 3x plus 8 is equal to 0, which will give me a negative 8/3. Check my math. And then I can't have a negative in here, I can't have 0 right here. I can have a negative, but the negatives don't count. So 0 is the only thing we're worried about. So x plus 4 is equal to 0. X is equal to -4. So our 2 points are at -4 and at what's -8/3? Is that what 2 2/3? 2.67 -8/3 right there, and then 0 right there. Now I'm gonna do something right here. I'm gonna take my, let's see, I don't have a white magic marker. So I'm going to take my red marker, which I never use red. Try not to. And you need to put an X through this. Why am I putting an X through this?
Can't happen.
I can't put a -5 in here because that'd blow the function up. 0 is going to blow the function up too. So you can't use -4 either. Okay.
0 will be fine.
I'm sorry, what?
Okay, never mind. You're good.
Okay, so pick a point. I'm going to pick a point. Let's go ahead and do 0. Plug in 0. You get 8 up here. You get a positive down here. So what do you get when you plug in 0? You get positives, Hubert. That's right, class. And I forgot to highlight my critical value. And plug in -2. Let's see, what is that? -3. Plug in -3. If you plug in a -3, you're going to get -9. You're going to get a negative up top and a positive on the bottom. So that means what are you going to get on the? You're going to get negatives. So we're decreasing here and increasing here. Okay, now what?
Second derivative.
Get that second derivative thing, old quotient rule. Oh no, we're gonna have to do a lot of writing. Yeah. That's why you want somebody that's been through calculus to dang old build a bridge. Dang on, so that thing won't fall. So I'm going over here and I'm going to put f prime of x is equal to 3x plus 8 over 2 times the square root of x plus 4. And it is 410 right now, so I want you to do it. I'll give you 2 minutes. And if you can't do it in 2 minutes, that means, oh man, that means I'm very sad. I didn't say get it right. I just said get through it. So if you could write down a half a page of stuff in 2 minutes, then I guess you're okay. Not that you got it right or anything, but. I'll go ahead and set it up for you. Denominator times numerator prime. I got to use my colors. Minus brackets numerator times the denominator prime. Thank God for the chain rule. Over the denominator squared. That's what you should be starting with. Didn't appreciate that chain rule. I bet y'all appreciate it now.
I've appreciated it since day one.
Listen, that chain rule is one of the best rules there are. One more minute. Let's go with pink to do the derivative. I'll go ahead and be writing all the black down. Okay, so what is the derivative of 3x plus 8?
3.
3.
Good job. And what is 1/2 times 2?
1.
So I'm going to put a dotted 1 right there, meaning you don't have to do that. And then x plus 4 to the what?
-1.
3 halves. -3 halves.
Negative 1/2.
Oh, sorry.
Or it was,
It looks like a 2 halves.
yeah,
It's really tiny on my computer.
I'm sorry. It's my fault.
No,
Okay.
it's mine. I have a tiny computer.
Oh, you do?
Yeah.
Well, you need to get in the man cave and get you a 52-inch screen to hook up to your computer. I'm kidding. All right. So now simplify, because guess what? Guess what?
What?
There's no more calculus.
I think I just heard someone throw up.
I think they were just doing a surprise. There's no more calculus. Y'all probably sick of me saying that. But a lot of people think calculus is hard. It's not. It's the algebra that gets you. Because I guarantee you, there's a lot of people, if you walked up to them and gave them this right here, they couldn't do it. And we've already done the calculus. So f prime double prime of x is equal to 6 square root of x plus 4. I'm just going to leave that in the brackets for right now. 3x plus 4 times x plus 4 to the negative 1/2. I'm going to bring that down stairs, but not right
Priority
now.
1 message coming in on secure channel.
Over 4 times x plus 4. So now I'm going to write it. F double prime of x is equal to 6 square root of x plus 4 over 1 minus 3x plus 4 over x plus 4 to the 1/2 power over 4 times x plus 4 over 1. Now, why am I putting everything in the form of a fraction?
Combinations and simplifications.
I'm sorry, I heard mumbling. What?
Combinations and simplifications.
Yes, we're going to take this. This is called a complex rational equation. We're going to multiply by, pick a color. Let's go with that nasty yellow. I'm going to multiply by x plus 4 to the 1/2 power over x plus 4 to the 1/2 power. I'm going to get rid of that fraction by multiplying through by the common denominator over the common denominator. So go ahead and do that. Now remember, this is x plus 4 to the 1/2. So you're going to add the exponents. And this is 2/2. So you're going to add the exponents. No, wait a minute. No, that's you can't. Well, you can 3/2. It's just going to come out and be. You could. You don't want to do that. Just leave it. Leave it as x plus 4. It'd be x plus 4 to the 3/2 if you did. And when you get through, when you get through, you're going to get this. F double prime of x is equal to 3x plus 16 over 4 times x plus 4 times the square root of x plus 4, or 3x plus 16 over 4 times x plus 4 to the 3/2 power. Now set that equal to, you're going to set 3x plus 16 equal to 0. And you're going to set x plus 4 is equal to 0. And that's going to give you x is equal to negative 16/3. And x is equal to negative 4. Let's see, this is negative 4. Wait a minute. That's negative 5 1/3, isn't it? 5 1/3. So we don't, so it belongs down here with the nasties. So that's down here, negative 5 1/3. So technically 4. You don't want to put a 0 there because that'd make a 0 here and that'd blow up the function. So it's non-inclusive of negative 4. So we just got 1 point to pick, 0. 0 gives you a positive. 0 gives you a what? Positive. So it looks like this function is all positive.
Are you saying things are looking up?
Negative, yeah, looking positive. All right, negative 4. Remember, negative 4 is our inflection point. So we've got nothing over here because this doesn't exist. So we've got concave what?
Up.
Concave up. And our previous, we've got nothing. We've got nothing at negative 4 and then a decrease with an increase. So that means that we've got from negative 4, it's decreasing. That's right. And then at 8/3, that's probably our vertex. Negative 8/3 from our previous number line, and then it's increasing. So that fits because it's concave up. So let's graph it and see what it looks like. Take our handy dandy graph, and we're going to graph y is equal to, turn it on, y is equal to x times the square root of, where's the square root symbol? Isn't it above?
Second, And then squared.
Second square right here. I can't see that blue very well. And then parentheses, x plus 4. Close parentheses, delete. Why does it go backwards? Delete, 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 delete. Now it's working. There.
Gotta hit delete one more time.
Dadgummit. Graph. Look there. It's a miracle. And again, the reason I'm showing you this is because you need to be able to, you know, especially from the business aspect, you got to be able to find the increase and decrease in values as well as the inflection points. I'm going to give you this one for homework. This will be one question, and I'm going to give you some more homework questions, probably either today or tomorrow, and it'll be like 5 or 6 questions. It'll be called Hubert's Increase and Decrease in Inflection Homework. F of x is equal to x to the 4/3 plus 4x to the 1/3. All right, that's your homework for tonight. And continue to work, and please don't fret about 5.1 and 5.2 and maybe even 5.3, because I'm going to look at the grades, and I'm going to do something on y'all. I want y'all to focus on 5.4, 5.5 Hubert's and what I'm doing now. Okay, if I had my druthers, I would go back and take 5.1, 5.3 off, but I can't do that now that y'all started. So I want you to just focus on 5.4, 5.5, Hubert's homework, and then this question right here, and what I give you the next couple of days. Because what I'm going to try to do is give y'all the weekend to work on these 2 new homeworks, and that way Monday, Tuesday, and Wednesday we'll do nothing but answer questions.
Sounds like a plan.
Well, that's my plan. I'm sticking to it. All right, now I can do the roll because I can see y'all's names over there. I just got to fix it. I got to turn off. Let me turn on who's in class and turn off the recording.